But hey, we're back once again. What you see on the screen might be quite familiar if you've watched a couple of my videos before, but it's actually something completely different. We'll get to that in a second. This is... Oh, I closed the tab, actually, that this was on. There we go. This is a Rat Run homage. So Rat Run, if you don't know, is the incredible puzzle series made by Marty Sears with 20 puzzles in it. And from what I understand, there might be even more coming eventually. But yeah, these are all incredible. I've made videos on most of them. Not all of them, but I've made videos on most of them. And they were super fun. I enjoyed them very, very much. But now we have people doing homages to them. In fact, this was made last month. I took note of this puzzle all the way last month, but I never actually did it because I'm a little scared. Because it is 4-star difficulty, so this might take quite a bit of time. But we'll try to get through it, we'll do our best, and we'll see where we land. Anyway, let's get started. So, normal Sudoku rules apply. So we have to put digits 1 through 9 in every row, every column, and every 3x3 box once without repeating. Don't worry about these purple lines yet. These black, kind of more shaded line, more like thicker lines, they're the ones that delineate the 3x3 boxes. And the purple lines are instead part of the maze, which we'll talk about now. Moose the mouse, not Finks, Moose the mouse must reach the cupcake, and Felix the cat must reach the escape hatch, finding paths through the maze. Individually, the paths may not visit any cell more than once, cross itself, or pass through any thick maze walls. As well as moving orthogonally, both Moose and Felix can move diagonally if there's a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. Importantly, the paths of Felix and Moose can cross each other. This can only happen on even digits, and if it does ever happen, both paths must go straight across. So there's a lot to talk about there. So let's take it, one step at a time. So basically, we're gonna have to draw paths in this puzzle. So Moose starts right here. I don't know Moose's gender. They might take a path like this to the cupcake, right? I can assure you that's not the path, but we'll talk about that in a second. And then Felix has to reach the hole here, right? So they might take a path like that. What they can't do, what they can do, first of all, is that they can move diagonally if it's something like this. So if there's no wall in there, Felix can move diagonally here. What Felix cannot do is something like that, because that would be passing through a rounded wall spot. That's just not allowed. What can also happen, and I believe, in fact, this has an example of crossing of paths. So their paths may cross if something like this happens. So let me see where that may be able to happen. Let's say, okay, well, I'm not going to draw the entire path, but let's just say that is part of Moose's path, and this is part of Felix's. That would be allowed, because they're crossing on like 90 degrees, and they're both continuing across, straight across. What's not allowed is for them to cross and then one of them turns during the cross. And also this can only happen in even digits, so this digit would be even. Anyway, one-way doors. Moose and Felix may only pass through black arrows if moving the direction the arrow is pointing. An arrow always points to the smaller of the two values it sits between. So the path I drew here for Moose is not possible because they'd be passing through an arrow in the wrong direction. This, on the other hand, would be possible. And this digit would be bigger than that digit. And that's the case everywhere, not just on arrows that they pass through. Black currents. Cells connected by a black current have a 1 to 2 ratio. One is double the other. Not all possible black currents are given. So these two cells have a 1 to 2 ratio. So if that's a 1, that's a 2. If that's a 2, this is a 1 or a 4. Pretty simple. Grapes. Digits separated by a grape, a green grape, have a difference of at least 5. Not all grapes have necessarily been given. So if this is a 9, that couldn't be, say, a 6, because those only have a difference of 3. That would have to be at most a 4. Pretty simple. And then path constraints. So both of the paths that we draw are going to have slightly different constraints. For moose, the path within each box must be a thermometer, with the bulb being the first square entered and the tip being the last square in the box. Repeat visits to the same box are considered separate thermos. Okay, so let's say this is the starting path that moose makes. What that's saying is that this digit would be the smallest of this group of digits, and then this digit would be bigger than that, this digit would be bigger than that, this digit would be bigger than that, and so on until we get to the end of the box, and then it restarts, right? So this digit could be anything. It's not related to what this is. For Felix, adjacent cells along the path must be of different parity. So for Felix's path, it's a little simpler to understand. If this is even, that is odd. If that's even, then that's odd. So on. And those are the rules. It's a lot. And I'm not sure that I'll be able to finish this puzzle. If I'm not, well, you won't be seeing this video. So I guess I don't really have to say that, do I? Now that I'm thinking about it, I think I did actually try to record this video before, closer to when this puzzle released. And I just couldn't because I was too tired. And it was kind of hard. But we'll try again. We'll do our best this time, yeah? So, first of all, I think the colors that I'm going to choose for the two paths are going to be green and red. I'll do green for Moose and red for Felix. Also that I drew there. Yeah, Moose's path must start like this, because that's the only way they can go. Okay? Now, Moose has a choice. They can't go right, because that would be crossing through an arrow in the wrong direction. But they could go up, or they could go left. If they go left, that tells us even more, because then they'd be forced to go down, left, up, up. And then they'd be forced to do even more stuff, because from here they couldn't go up, because they would be crossing through an arrow in the wrong direction, so they'd be forced to go there. And then they'd have to go either up or left up. Okay. Oh, 1 second. I'm actually have to pause this recording. I'll be right back. Sorry about that, we're back. I'm having some, like, weird memories of this puzzle, if I'm honest. I think maybe I did actually get kind of far when I tried recording this in the past, because I feel like I've said a lot of these things before. What I'm hoping is that I didn't somehow accidentally post this puzzle already to my channel, and I'm just redoing it and forgetting about it. I don't think that's the case. I checked my channel. There is no video posted with this puzzle. So, if that is the case, then I don't know. Maybe I did it in like an alternate universe and I'm just thinking about it. Who knows? Okay, well, one other thing that I can say is that whatever path Moose takes, they're gonna end up in this cell eventually. Because if they go up, they have to keep going up, up, left, and they end up in a cell. And if they go left, it's that path that I told you, and they end up in this cell once again. So, I'm silly. They can't go left. Because remember, Moose's path acts as a thermometer. So, the digits must go up in a thermometer, right? So they go up, 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 up. That's not right, because this digit should be bigger than that digit. But by thermometer, this digit should be bigger than that digit. That's a contradiction. So we're definitely not going to go left. We're actually going to go just up, and then left there. And that's the start of the path. I think, unfortunately, that's all that we're going to be able to tell about that path right away. But it was a good start for what we got. I'm trying to think of how we're gonna start Felix's path, the cat. because Felix has a lot of options for what they can do. They could go up, they could go not like that. Diagonal here, they could go right. From there, they could do a little loop-de-loop. They could do some weird stuff. They could go, I don't know. Well, okay, there is one thing I know. And this is a small point, but I should say this. The animals can never touch the opposite animal's goal. So what I mean by that is Felix can never touch the cupcake. Because, well, that wouldn't end Felix's path, right? So Felix would have to keep going. But eventually, Moose is going to reach the cupcake. So that would mean they would cross. But remember, if they're crossing, both paths must go straight across. Which means somehow Moose's path would have to go, like, beyond the grid. And that's just not going to happen. So, and the same thing applies to the hole that Felix is going to go into. So Moose is never going to go past the hole, and Felix is never going to go past the cupcake. Which does tell us something. Yeah, no, that actually tells us a lot. Okay. Because before, I was thinking, there's so many ways that Felix could go. They could go here, they could go here, or they could go here to exit their box. Well, actually, only one of those is possible. Because if they go here, they are going to touch the cupcake, and that's not allowed from what we said. But now you might think, okay, so what's the problem with them going there? That's fine, right? Well, no, because remember, Felix's line must act as a parity line. So it must alternate between odd, even, odd, even, odd, even. Now, can that happen in this little sequence of black dots? And I'm going to say the answer to that is no. Because let's just think about the two examples, yeah? If this was odd, the only two odd digits that can be on black dots in Sudoku are 1 and 3. So if this is a 1, both of these would have to be 2, not allowed. If this is a 3, both of these would have to be 6, not allowed. So instead, let's try the other way. These are both odd, and that's even. Well, once again, these can only be 1 and 3, so they'd have to be a 1-3 pair. Well, I'm going to tell you right now, there is no digit that is 2 times or half of both 1 and 3. You can try any digit you want, you're not going to find one that fits in here. So Felix does not go there, which means they do go here. Which actually tells us even more stuff. Because now they're in this box. They're in box 8 here. Well, how do they exit this box? They're not going to exit through here, because again, they'd have to go through the cupcake. They're not going to exit through here, because that would be going through an arrow in the wrong direction. So they're actually going to exit through here, and that is a crossing of the paths. Which, well, first things first, that is an even digit. So I'm gonna say that's 4, 6, or 8. Because it has to be at least a 4, right? Because remember, Moses' line acts as a thermometer. If this was 1, this could be 2, 3, 4. So this is definitely not a 2. It is a 4, 6, or an 8. Which I'm going to say means that that is a 2, 4, 8, or 6. Of which we can say it's not, or not 6, excuse me, 3. Of which we can say it's not an 8. Because if it was an 8, it would go 8, 9, nothing. Can't be filled. So this is a 2, 3, or 4. What I like doing in puzzles where I have to think about how big digits are is I like coloring them based on if they're below 5 or above 5. Now, usually that's more important in puzzles with German whispers, which we don't have a lot of here. These grapes actually do act as German whisper, like, short lines. I'll talk about what that means in a second. But what I'm going to do, just to keep my mind working, is that I'm going to color digits that are below 5 blue, digits that are above 5 red, and 5s I'm going to color green. Okay? Okay. By the way, Finks' path must continue through here. Can't go up, because that would be crossing through a arrow in the wrong way. So it's going to do that, actually. And now these are crossing, so they must go straight. Oh, this puzzle's brilliant already. We don't go down from here, because then we'd be crossing Felix's path incorrectly. So we go up. Felix's path also goes up. And now I'm not quite sure what happens, but let me check what else I can do. So what is the minimum this digit can be now? If this is a 2, 3, 4, 5, 6. So this is definitely at least a 6. So I'm going to color it red. And now, what? This is even. So this is definitely odd, and it is bigger than that. So it is a 5, 7, whoopsie daisy. It is a 5, 7, or a 9. This is odd. This is even. This is odd. Even, odd, even, odd, even. Odd, even. The other, okay. I'm actually gonna do it a little differently, I think. So there was an old series that I played that was, I believe, equality cages or equality lines, where you had to think a lot about what digits were small and big, and even and odd. And we're gonna have to do the same thing here. So what I might do, actually, yeah, how am I gonna do this? Because I want to mark what's even and what's odd, but I also want to mark what's small and what's large. Maybe, okay, you know what? Maybe I hold off on marking small and large for now. I think marking even and odd is going to be more useful. So this is even. I'm going to color evens blue instead. So I'm changing the rules. Blue does not mean small digit anymore. It means even. I apologize for changing it like that all of a sudden, but I think it'll make it a little easier actually to think about. So this is definitely even, and I'm going to color odds orange. Yes, those are the colors that Cracking the Cryptic does. Sue me. Please don't. This is even. And it's at least 2, 3, 4, 5. It's at least a 6. So it's actually a 6 or an 8. Oh, yeah, this is already useful. Because now look at this column. There's 4 even digits on it. Well, there's only 4 even digits in Sudoku. So these are both odd. And now, what can we do? That was a lot that just happened. I'm going to be honest with you. But where does that leave me? I'm not sure. This can't be a 9, because then this wouldn't be able to be anything. I guess I'll mark that. That's not super useful. But this is a 1, 3, 5, or 7. The only way for this to be a 4... This is not a 4. Okay, this is not a 4. Because the only way for it to be a 4 would be if this was a 1, 2, 3, 4. But then what would this be? This would have to be a 2, and there would be 2 2s looking at each other. So that's not a 4. Which means that's not a 2. Which means now, this is at least a 3. Oh, this can't be a 6, because this is at least 6. 3, 4, 5, 6, 7. Okay, that works. Yes, this is a 6 or an 8. This is a 3 or 4. 3, 4, 5, 6. I guess I can mark this thermometer a little more. This is 4, 5, and 6. This is 5, 6, and 7. Because this could go 4, 6, 7, 8, 9. That's an okay thermometer to exist. Okay. Well, it was a good start. I'm not quite sure how to continue. We don't know much else about Felix's path. We don't know how it starts. We don't know how it gets here, and we don't know how it gets from here to there. We just know that that does happen. Okay. Well, what am I thinking now? I'm not sure. What can this be? This is even. Sorry, this is odd. This can be at most a 5, because it could go 5, 6, 7, 8. Right? Yeah. No, actually, wait. Does that not work? Let me try that, actually. If this is a 5, this would go 6, 7, 8. This would be a 4. This would be a 5, and then that's unfillable. Well, that's crazy, actually. So this can't be a 5. This is a 1 or a 3, somehow. Huh, that's weird. That's a really weird interaction. 6, 7. This can't be a 6. Because, yeah, then the 6, 7, forcing that to be a 5. Forcing that to be a 4, forcing that to be a 3. But this would be an 8, and that black dot doesn't work. So this can't be a 6. It's a 2, 3, or 4, or 5. That's not a very useful pencil mark. I'm actually going to delete that for now. This can be a 3. There's nothing stopping it from being that. How is this a 6? Oh, it's even because of Felix's line. True. If this is a 2, this must be a 1. And then this would be a 3. Okay. Okay, I'm a little confused, but let me see what else I can do. How long have I been recording, by the way? 20 minutes? That's already quite a bit. I feel like we're not even started with the puzzle yet, but, you know, we'll track on. What am I doing here? How do these paths continue? Because what I'm thinking is, it's possible for Moose's line to turn right, but then it'd be crossing Felix's line. So that would have to happen, and then that would have to happen. Which, just by looking at it, that seems fine, because this is still following the parity line. Felix's line would now be forced to turn right, because it can't turn left, otherwise it's stuck. So it'd be forced to turn right. That would be even. And then what? I don't know. A couple things could happen from that. If that doesn't happen, this goes up, and then it must go right. Which, since this is a thermometer and this is smaller than that, that would mean this is a 3 or 4. Because, yeah, one thing I haven't explained yet is these green dots, they act like something we usually call German whispers lines. And in German whispers, like it said, the digits must have a difference of at least 5, the adjacent digits. So if you think about that, well, first of all, can a 5 ever go on a green dot? Well, no. Because if it did, the other digit would have to be either a 0 or like a 10. And that's not going to happen. So every digit is either below 5 or above 5. And if this digit was, say, above 5, then we know for sure this one's below 5. Because even if you made this as big as possible, this would still be below 5 because it would be at most 4. It would be 1, 2, 3, or 4. So if we pass through here, we know that this has to be smaller than that. So this would be from below 4. And this would definitely be from above 4. And actually we'd know even more. We know a lot of stuff, actually, because this can't be a 1 or a 2, because it's on the third cell of the thermometer. So this would be a 3 or 4, meaning this can be a 6 or 7. But also, this one can't be a 9, because, well, we're not out of the box yet. We still have to move a little more, at least one more cell. So this would be forced to be an 8, meaning that would be forced to be a 3, 2, 1 there. That would be a 9, and then we'd be forced to move out of the box immediately, because we're out of digits. That would actually force this to be a 6. 5, 4, 3, 6. That would force so much stuff. Yeah, if we move up in Moose's path, that forces so much stuff. That would be really, really good. That'd be huge, actually. But I'm not sure we can prove that is the problem. What the heck can I do here? I mean, I can say a small thing I know is that Felix's path, it's gonna end in this box. I know, shocker. The hole's right there, so yeah, shocker. It's gonna end in this box. How do we get inside of that box? We don't get there through here, because wrong arrow direction. We don't get there through here, because we already said this, Felix can't go through that. So we do get there through here. So Felix's path is gonna go into this box, and then into this box. And then the only way of getting into this box is through this box. So Felix's path is gonna end by going between these 3 boxes. That's not a super big deduction, but it's something. That... Unfortunately, I don't think we can play the same game with Moose. Because Moose has to get inside of this box. But there are 2 ways it can do that. It can come from here, or from here. It can't come from here, because then the 2 paths would overlap, and that's just not going to be allowed by the rules. But it could come from here, or it could come from right here. Golly gosh. Oh gosh, 1 second. Sorry for the other interruption in this video, but I might have to pause for another second. I'll be right back. Okay, I'm back again. Hopefully, that'll be the last interruption for the time being. Where was I? If this is a 4, this is actually forced to be an 8. Which actually tells us a lot. Because, yeah, if this is a 4, this is at least a 5, at least a 6. So this couldn't be a 6. This would be an 8, making that a 9, making that an 8 for that red, black dot. And so by Sudoku, the 8 would be up here, but it can't be there, because then this would be a 9, and this path can't go anywhere. It also can't be there, because then the next cell in the path would be a 9, and then it can't go anywhere, so 8 would actually be right there, which would mean a couple things. First of all, it would mean this can't happen, because then that would be a small digit, because this is large. So this would instead be forced to move right, and then this would be forced to move here, and this would be 1 or 3. That would also do a lot. If this is a 4. But I don't think we can prove that quite yet. What do I do? I'm not sure. This has to be bigger than that. I'm sorry, this can't be a 5 anymore. This is 7 or 9. My bad. Yeah, that's from when we thought this could be a 4. That's why I wrote 5 there. Okay. What can I do here? If, weirdly enough, yeah. Weirdly enough, if this is a 3, this is forced to be an 8. Because if it's a 6, it would have to go 4, 5, and then that can't be filled. So if that's a 3, this is an 8. Which would force all those things that we said before. So somehow, if that's a 3, that means that this moves right. Which, yeah, that's Sudoku, baby. I'm not sure. Oh, I forgot to undraw this. That's not supposed to be there. That was from a thought I had. I'm not sure. It's complicated. Again, it is very possible that I just won't be able to solve this one. Today. I hope that I can. But it's possible that I can't. If this is a 6, that's a 5, 4, 3, then that's a 6. And by Sudoku, the 6 is up there, but it doesn't have the same power as the 8, because this could even be a 6. If that's a 7, and then maybe 8 and 9, and that's how the path moves. Well, either way though, can this move up? No? It could. No, it could. No, it can't. Can it? Hold on. Can this move up? Because if it moves up, it moves right. And then this can't be a 6, because then that would be small, and that's not going to happen. So at most, this is a 6. No. No, okay, hold on. I think we've disproven that this can go up here. Okay, so let me redo that entire thought process, okay? So there's 2 possibilities. Either this is an 8. No. Never mind, there's more than 2 possibilities. There's still the possibility where this is an 8 and this is a 6. I didn't think of that. I did not think of that. This would be forced to be a 9. But that's not very useful. Because now these aren't the same, so I can't say anything about Sudoku. Shoot! Close. Close. We were close. I think we did prove that if these are the same, then this can't go up. Because then by Sudoku, whatever digit these are would have to go in that column. And we just can't put it on the line while also having the line go upwards through there. in fact, like we said, for this line to go up, this has to be small and that large. That would be forced to be an 8. That's a 3, 2, 1. Yeah, that would force a lot. Oh, that would force to be 8, which would make that a 6. Oh, no. Yep, that works. It doesn't work. It just doesn't work. It just doesn't work. I just didn't notice it. Okay. This can't go up. Because if it does, like we said before, this has to be small and at least a 3. This has to be large and must be at least 5 different from that. So it'd be an 8 or a 9. It can't be a 9 because then it would be stuck. So it's an 8 and then that's a 3. By thermometer, that's a 2, 1. Now that's a 6. 5, 4, 3, 6. Where the fuck is the 6 in this column? It's nowhere. It can't be there by Sudoku. It can't be there by Sudoku. It can't be there because that's not the digits that are there. So we don't go up. We actually do go right, and then the paths do cross. So we must do that. There we go. Wow. That was a lot, but hopefully now we'll be able to do a bit more. Yeah, okay, so now this path can't go left because it would be stuck. So it must go right, which means that is even now. Small win, but a win nonetheless. Now, the heck can this be? Can't be a 2, because this is at least a 3, but it's even, so it's a 4, 6, or an 8. I mean, the 2 in this column is still unaccounted for. It's in one of those. If it's here, this is a 1. Is that possible? Is there a problem with that? 2, 1 would force that to be a 3. Which would force that to be an 8, like we said. Force that to be a 4. Force that to be an 8. Neither of these can be 8. Because that just doesn't work by thermometer, so that would be forced to be 8. Which would make that a 1, 2, or... It would make that a 1, actually. That would force quite a bit of stuff. This would be a 9. This would be a 6. That would be a 4. These would be 2, 3 in that exact order. That would force so much. Oh my god. Huh. This would be a 5, that would be a 7. Sorry, I again had to look at something. My phone is just not good today. That somehow doesn't work. Look at this. This is a 5, 7, or 9 by this column, but it can't be any of them. So, and that entire thing was because we made that a 2. So in fact, this is a 2. Somehow. Which would mean this is a 4, 6, or an 8. Don't know what that tells us, but we have a digit now. That's cool. I don't know what to do with that. It's a problem. happens now? Where can Felix's path go now? It could go right or down. If it goes down, it must keep going down, and then this goes like that. And then this would be forced to go there. Paths are crossing a lot more than I thought they would. It's already been 3 crossings. That's crazy. These are... whoops. These are both even. Okay. What can I do with that? Not sure. Oh. Sorry about that. Pop up. Hopefully I didn't show up in the recording. Hope not. Recording's still good? Yeah, it's still good. It's been 40 minutes, really? That's crazy. I feel like I haven't even started. The heck do I do? Three. 6. Don't wait for that to be a 6 if that's a 3. Like this side. And then that would be a 6. And then 6 would go either here, here, or here. Actually, it could go in any of those spots. If it goes in either of these, that's an 8. And then that's a 9. But I can't be sure if that being right. Jeez. Okay. Felix's path can't be too much longer, I don't think. Because it's going to enter this box. And then the only possible thing it could do is take a detour into this box before re-entering this box, going over here, and then going to its final box. To get in the hole. But I think taking a detour over here would be kind of difficult. Because it would have to enter through here and exit through there. Because it can't do this. Because then it'd be stuck. It couldn't exit from anywhere. It can't exit through there, there, or there, because it would be crossing its own path, or the cupcake. So it'd have to enter through here, exit through there. And then go into this box, and then into this box. I'm not sure how we're going to do that. Or we just go from this directly to that. Not sure. Can't really say too much about Moose's path as a problem. Because Moose might be able to... they're going to go here, obviously, because that's the only way they can go right now. But then they might go down and then down again to the cupcake. Or they could even go right and then down over here through this path into the cupcake. That's possible. I don't see why not. I don't see why that would be impossible. In fact, must that happen somehow? Must that happen? Can I prove somehow that must happen? I don't know if I can. That's the problem. I'm not sure. I hope that I don't need to scrap this recording and try again some other time. Because like I said, I'm pretty sure I've already done that once for this puzzle. I don't want to do it again. But I feel quite stuck. And it's been 45 minutes. We figured a couple of things out, in those 45 minutes, but not. I haven't gotten super far. We only have one digit. We don't know anything about this part of the grid, really. Let's see. Mousetrap. Am I missing any rules? I don't think so. Cross each other, even digit. I don't know. I really don't know. Where can the green path go? It can't go up, because then we'd be crossing this path and we can't go straight from there. Could go down, which would immediately make us turn. In that world, this couldn't be an 8, because then it would go 8, 9, nothing. So this would be a 4 or 6. This... nothing. There's nothing I can say about that, really. And then the other option is that we just go straight right. So we are going to end up in one of these two cells. And then what happens from there? Many possibilities. We could go down here, we could go through there. I really don't know. Yikes. Just trying to figure out if there's something I haven't looked at. But I feel like I've looked at everything. If that's a 3, like we said, that's an 8. And this is a 4, 5, 6, 8. 8 would have to go up here. It can't go in either of these, so go there. This would now be a 1. This would now be a 1. So if that's a 3, that's a 1 somehow. And these are 5, 7, and 9, those 3. That's a 9, so this can't be a 9. Either this is a 5, or if it's a 6, that's a 7. So 5 and 7 would be in those 3 cells. This couldn't be an 8, that couldn't be an 8, so that couldn't be a 7, that can't be a 3, that's not a 4, so that's not a 5. 6 would be forced to be there. These would be from those digits. It's not super constraining. I mean, yeah, a lot of things would happen if we just figured out like one more digit in this puzzle, but I don't know how to do that. If that's a 6, like we said, that can't be a 3, so it would actually be a 1. Is that anything? That would be a 3. These can't be 6s. That can't be a 6, that can't be a 1. 4, 5, 6, 5, 7, not 8. Man. Just not sure. Did I think of it backwards? If that's an 8, these aren't 8s. And these are from 1, 2, 3, and 4, and 5. If that's a 6 instead, then we go 5, 4, 3, 6. That's not a 6. 6 has to go up here. But that's the problem. It can go in the line, technically. If it goes here, this is a 1, like last time. Which would be useful, because then we might be able to prove that this is a 1. Wait. How do we do that? If that's a 1, can that be an 8? So just go 4, 5, 6, 8. 8, 1. No, 8, 3. I mean, that still works, yeah. What about if that's a 3? Then that's 8, like we said. 4, 5, 6, 8. 8 here and 1 there. So if that's a 3, that's a 1. If that's a 1, that's a 3. That's really weird. So these are actually a 1, 3 pair. These two. Is that right? That can't be right. Let me think of that again. I think I fucked up something there. If that's a 1, no. I didn't think of this possibility there. Yeah. I don't know what this is. Just know that these aren't 6s. In this world. Six in this case would be in one of these two cells. It can't be in odd cells, and it's not there. So it'd be either here or there. If it's there, no, but it could still be in that line. Ah! What am I doing? I thought I had somehow proven that this was small, but no, I haven't. I think I've proven that if this is 8, then that's small. But yeah, that's kind of obvious. Then we go 4, 5, 6, 8. Then 8 goes there, and then that's whatever that digit is not. If that's a 3, that's a 1. If that's a 1, that's a 3. So if that's an 8, then these are a 1, 3 pair. If this is a 6, we go 5, 4, 3, 6. 6 now goes up there, and I still don't know. Okay. It's been 55 minutes, really? I mean, I really hope I don't have to scrap this. I really, really do, but I just haven't gotten anywhere in like an hour. 2, 3, this is from 3, 4, 5, 6, 7. I'm just gonna try out writing stuff now and seeing where it gets me. That can't be a 4. No, it can. Jesus! That can be a 4 if that's a 2. And this would be a 1. That'll be a 3. That'll be a 6. Can this be a 7? That would be an 8. That would be a 4. Can this be a 6? That would be a 7. That would be an 8. That would be a 5, 4, 3. Okay, so that can't be a 6. That's some information, I guess. Just trying out things at this point. Seeing what works, what doesn't. This is now 5. Yeah, no. I also can't be a 5 somehow. So this would be either a 6, which would make that happen, or it would be a 7, which would make that happen. So that also can't be a 5 somehow. Okay, can it be a 4 now? I think 4 it can be. Because then this can be... No. That doesn't work. What about this? No, that doesn't work. Huh, that can't be a 4. What? Is this gonna be the cell? Are you serious? That's a 3 instead. That can't be a 4, because that would be impossible. 5, 6, 4, no. 6, 8, 4, 5, 7. That's, like, barely possible. And then 8, 9. 4 there, 1 there, 6 there. But that doesn't work. 4 is not bigger than 5 or 7. Oh my god. Did I figure it out? Last option. That's a 7. That's an 8. That's a 4. That's a 1. That's a 5 now. Which means that's a 6. That's an 8. That's a 9. That's a 4. No, come on. Please don't work. Please don't work. I was really hoping that didn't work. Damn it. I think that does work. Like, barely. This can't be a 4, that can't be a 7, but now these are 5, 6 pair in that order. Darn it. Okay, well, what we did prove is that if this is a 3, that is a 7. Now, what about if this is a 2? Well, first of all, that would be a 1. And now what happens? 3, 4, 8. Nothing. 4, 3, 6, 5, 7, 8, 9. That is not fillable. So this can't be a 4. What about 5? Unknown. Well, this is not a 6 because that can't be a 5, so that would actually be an 8. That would be a 9. Those aren't 8s. It's not a 1 or a 5. Those are 5s. Okay, so it can be a 5. What about 6? I'm just going through all the possibilities at this point. What about 7? Like nothing. Like nothing happens to 7. Damn, okay. Barely. So if this is a 3, that's forced to be a 7. But if it's a 2, this could be a couple things. This can't be a 4, like we said. So maybe, I don't know. Can we prove where 2 is in this column? Because right now it can only be there. Can't be in any of these. Can't be there, because this is at least a... Well, it's at least a 5, actually, because this is a 4. At least a 4. Could be there or there, though. What about 1 in this column? Yeah, what about 1 in this column? It can't be in any of these. Can't be there because that's even. Can't be there, so it is actually here. That's a 1. Okay, that's something. 1 is in one of those. So 2 now can only be down there or right up there. That's a 2, that's huge. That's a 3, that's even huger. But can I prove that? If that's... If that's a 3, what happens again? That's a 6, that's a 2, that's a 1. That's a 5. That's a 4, that's a 7. That's an 8, 9. 4 here, 6 there, 3 there. So that's a 3, that proves a lot. If that's a 3, that proves a lot. What is that? Oh. Well, that's something, isn't it? Let me take a picture of this, actually. Because I just realized something. 3 can only be in one of those 2 spots. Here. No, it could be here still. Damn it! What happens 3 is there? 3 is there, 2 is there, 1 is there, 4 is there. 8 is there. That can't be a 4, that's a 6. 8, 4, 9. 6 is bigger than 5. That'll be a 4. Well, okay. The other option I was thinking of is if that's a 3. Because 3 can only be in one of those 3 spots. I think. No, it's wrong. Could be. Oh, that's a 1. Sorry. I forgot to put 1. Can't be here, because this is at least a 5. Can't be here, because that's even. So 3 is in one of these 3 spots. Okay. If 3's here, that's 7, like we said. If 3's here, that's 3, like we said. If 3's here, that ends up being what? 5. So there's no way this is a 6, right? Can I disprove that another way? If that's a 6, that's an 8, that's a 4. That's a 5. That's a 7. That's a 4. That's now 1 or a 3, so that's a 2. That's an 8. That's a 9. That's a 6. Why is that wrong? Yeah, because now 3 is nowhere in this column. Can't go there or there. So, by a very convoluted way of proving that's not a 6. Which actually does tell us it's odd. Which is nice, in a way. But it's definitely a 3, 5, or a 7. Okay. Golly gosh. In what world is this a 5? Yeah. I don't remember, to be honest with you. I'm getting tired. It's been like an hour. It's been like an hour, 5 minutes, really. I don't know. I might not finish this today. I'm stupid. This can't be a 3. What am I doing? This is a 2 or a 3. This obviously can't be a 3. That's a 1. Now 1 is in one of those. That's not a 1. Apologize. That's not super helpful, but I should have seen that, like, way sooner. Maybe I am kind of tired. I didn't match. Well, now we actually know this can't go down, though, because there's a 1 there. So this actually does go straight. This is from 5, 6, 7, 8, 9. This is at least 4. What about this? Oh, here's one thing. This can't go down now. Because if it did, whoops, wrong color. If it did, it would have to keep going across, and then that's even, odd, even, but that's not even, that's odd. So this does not go down, this actually goes across, which means that's odd. Okay, jeez, we figured something out. We're still going. Still going. It has been an hour, 5 minutes, but we're still moving along, slowly but surely. Somehow. Huh. Let me look at those pictures that I took. Okay. Okay. Jeez. That can't be a 7, I don't think, actually. Because an 8 and 9 have to go into the box somehow. They can't go in there. They can't go in there because 8 is not odd. Yeah, 8 would not be placeable anywhere if that's a 7. So that's actually not a 7, that's an 8 right now. That's slightly better, I guess. Actually, yeah, these are both odd. 8 has to go somewhere in this box, doesn't it? If it's there, that's a 9, that's a 6. And then we know how things go. They go like this. And these would be 1, 7 in that direction. Sorry. That would be the 8 in that column, that would be the 9, that would be the 4. 8 there. That would do a lot. Eight is there, I think the exact same thing happens, doesn't it? Because then, yeah, because then we have the exact same kind of arrangement. What about if 8 is here? So that's the only other place it can be. That would be a 9. Not sure. If 8 isn't one of these two, we know a lot of stuff. Otherwise, it's right there. Can't be in any other place in this box. It can only be in those three. One is definitely one of those two, like we said. Oh, there we go. I solved it. No, I didn't. Sorry. 2 in this box is either there or it's right there. If it wasn't there, that would be really good for us, but it could still be there. Jeez, okay. Well, what can we say about these lines now? If this goes down, it has to keep going down. And then it can't go over here, so it would have to go down again. This would be forced to go there. It can't go up, so it would be forced to do that. This now has to get out of this box, like we said. So that would happen, which would mean that would happen. And then that would happen when. And that would happen. Now these both need to get out through down. So I think that would happen. And maybe like it would cross like that. A lot of stuff would happen if it went down. Now if it went right, it goes down. Can't cross it like that, so it does that. Now it definitely doesn't go down, so it either goes right or up. Either way, it ends up in this box now. And now this goes down. In this scenario, it might still be able to go up and then through there. I'm not sure. Don't know. I'm missing something obvious at this point. It feels like I am. Nine in this box can only go in okay. 9 can't go anywhere in this column. It also can't go there because that's even. So that's actually 9. That's something. These are both odd, by the way. I don't know why I didn't color those. These are now from 3, 5, or 7. That's not a 5 because it's on a green dot. So it's 3 or 7. Which means that is 8 or 2. This can't be 1 or 9. So that is even, actually. Weirdly enough. Which means now there is an even and an odd in here. Just don't know in what order. Can 2 still be there? Yeah. Right? If 2 is there, that's an 8, which means that's a 3. That's a 9. That's a 3. 4, 8. 8 now goes there by Sudoku. It's not a 4, that's not a 5. It's not a 3, that's not a 3, that's not an 8. 4 is not bigger than any of those. 6, 5, 4, 7, 6, 5. These are now 5, 7, 9. That's the 9, 7. Sorry, not 5, 7, 9. Excuse me. Wait, yeah, 5, 7, 9. Sorry. That's wrong. Oh God, that's wrong. Where did that even start? With that being a 2. Ah, so that can't be a 2. Okay, we now know this is a 2. Oh my God, we figured something out. Now that's odd, because now we have all 4 evens in this box. That's 4, 6, or 8. What the heck does that tell us is the problem? Not much. That's a 2. That's a 2. That's great that that's a 2, but now what? Eight is either here or there. If 8 is here, this is 6, 3. If 8 is there, this is 4. Yeah, I don't know. These are from 3, 5, 7, and 9. Nine in this column is either there or there. How long is this recording? An hour, 17 minutes. Oh my stars. That's a 9, which is not super useful, because that doesn't tell us anything about this. This is an odd and an even. The odd is from 3, 5, and 7. Wait. No. Thought I had a useful idea, but not really. 6, 8. 5. No. 3. 3. No. 3 is in one of these 2 spots. It's not up there, like we said. 3 is there. 4, 8, 6, 5, 7. Three is there. 6, 5, 4, 7, 8. Let me compare those two. There's only 2 places where 3 can be. In one, that's a 3, and the other, that's a 5. So that can never be a 7. Which does it. Now 7 in this column is there. which means that's an 8. That's a 9. Oh my god. Okay. We've made progress. Oh my lord. That's not a 7 anymore. That's not a 9. 9 is here. 7 is here. 7 is here. 7 is bigger than 6. Oh my golly gosh. Oh my lord. That was a lot. That's even, and it's a 6. That's a 1. That's a 5. That's a 6. That's an 8. That's a 2, which means that's a 7. That's a 3. Going to just left in this column are 5 and 4, so they go in this order. And now what the heck? We've completed these entire columns in the span of like 2 seconds. Now I don't know what to do. This is from 1, 3, 5, and 9 now, somehow. What? What? Huh? Oh. Oh my god. What do I even do with that information? I've, again, somehow completed these entire columns. Just like that. And I feel like that's an entire puzzle in itself. It's taken me an hour, 20 minutes. But now I have no clue how to continue. Like, what do I do now? This is an odd and an even. Right now I have 2 odds and 2 evens in this row. This is 1 odd and 1 even. I don't know. I really don't. Can Felix's path go down? Because if it does, it can't go there because of caustic cake, so it would have to do that. I don't see why that's wrong, per se. There's 3 of each in there. I don't know. I really don't. 3, 4, 7, 8, 9. 4, 5, 6, 9. These are all correct thermometers. I just don't know how to continue. I feel like I'm stuck. This goes down. Then this whole shebang happens. And this shebang happens. And then that shebang happens. So these would both have to be even. These would all be odd. That would be even. That would be from 5, 7, that would be from 5 or 9. This would be from 2 or 4. Can't be 8 by the thermometer. 2, 4, 5. 2, 3, 4, 5. So this would be from 6 or 8. So I should be forced to be a 4 now. 2. So it can't be a 4 like that. That would be a 3. So if this goes down, that's a 2. But I don't know that it goes down. It goes across, like we said. And it does that. Yeah, yeah. And this goes down. These are now even. These are odd. 4, 6, 2, 6, 8. 1, 3, 7. 5, 7, 9. I don't know what I'm doing. Oh, now this says odd, so this these definitely don't cross going up. So this thermometer would be forced to go there. It's fine. It's bigger than that. Yeah, that makes sense. It's usually how these work. Bigger than the next one. It's not necessarily the case, but like, yeah, that's usually how they work. There's one thing I thought. If this crosses like that, these two still have to connect. So this would be crossing the red line somehow. Either in this square or in this square. Oh, not in that square actually, because then that's odd, even, odd. So that can't cross. So it would be crossing in this square, making that odd. Odd and small now. So 2 or 4. Shiz. Makes sense. From what that's saying. That would be large. An 8 or a 9. It would be an 8 actually, and then the cupcake would be a 9. Whoops, didn't mean that. That'd be even. 2 or 4. This would be large, not a 7, not a 6, 8 or 9. It would be 9, 8, because it couldn't be 9 because we're not done with this box yet, and that would be 9. If this crosses like that. Is that breaking thing? That's a 2 or 4. It's not an 8 now. 2, 4, and 6. Taken. That would actually be all of the even digits. That'd be odd. So all those would be odd. This would be from 5, 7, and 9. So far this is seeming to work, unfortunately. That would be a 1 or 3, with that being a 2 or 6. That would actually be like that. Now I think makes it hard for this thermometer to work. Because it wouldn't be able to cross to 2, because then this would be forced to be a 1. So we'd have to go around. And now this goes 3, 4, 5, 6, 7. That can't be filled. Oh my god. I think I somehow was actually able to prove that that's not correct. And that entire train of thought started from where? From this going right. So instead, I believe this actually does go down. And this goes like this. And like that. And like this, and like that, and like that. And these are even. These are all odd. This is even. This is 2, 4, 6. These are 2, 4. That's not an 8. 2, 4, 5. 6 or 8 there. 5, 7, or 9 there, not a 7. 1, 3, or 7. 1, 3, or 5. 2, 3, 4, 5, 6. 2 there. Oh my god. 4, 5, 6, or 7. 5, 6, or 7. 1 is now up here, so 1 is there. This thermometer keeps going, which means it keeps going. This, I don't know what it does in this little 2x2, but it exits through there. Sorry, what am I saying? 1 is up here. 1 can be in these as well. I'm not sure what I was on there. My bad. 3, 4 is a, no, 4 could be there. 5, 6, 7, 8. 8 can only be right there, so that is an 8. Wow, okay, I think we're actually in the right path, somehow. What? I think we're actually in the right train of thought. I don't know how, but I think we are. What? Weird. This is one of each. So these are one of each. To complete the parity in this row. How long have I been recording? 1 hour 30 minutes. I'm committed to finishing this now. I've gotten this far. Dude, now it's... I can't stop. Okay. Here's an interesting thing. These two parts of the path can't connect without the cat moving diagonally somehow. Because if he didn't, if we only move orthogonally, then we go even, odd, even, odd, even, odd, even. But that's supposed to be odd. So we are going to have to move diagonally to kind of stagger that a bit. So even, odd, even, odd, even, odd. So we are going to move diagonally somehow in these cells. I have no idea where. That's a 1-2 pair. Wait, that's always a 1-2 pair. My bad. It doesn't have a 6 in it, so it's not a 3-6 pair. It doesn't have a 4, so it's not a 2-4 or a 4-8. That's always a 1-2 pair. In, whoops, daisy, in this order. That's not a 1. That's not a 1. Yeah, it's always a 1-2 pair. My bad. 2 is in there now by Sudoku. Somehow. That's odd. That's even. So the path can't move diagonally right now, because that would be the same parity. It could move down, it could move right. Don't know which it'll do. If it moves right, this is from 3 and 5 as well. It's not a 1, it's not a 7, it's not a 9. So that would be a 3-5 pair. That would be kind of good. The cat may still move diagonally here, so I can't say much about the parity of this, unfortunately. Like which one is which. If that's a 5, it's a 9, that's a 3, that's a 4. I don't see anything wrong with that, never mind. Thought that was going to do something, but it didn't. What is left in this row? We have 1, 2, missing 3, 7, 8, and 9. That's not an 8. So what can this be? This could be a small digit, if that's large. Or it could be 8 or 9. It can't be an 8. It can't be a 9. So that's actually not a 3. That is a large. That is a 7, 8, or 9. And then this is a small digit. That's interesting. That can't be a 7 or 9 because it's on a black crop key dot. That actually can't be a 3 either, because if it was, this would be a 6 and this would be another 3. So that's an 8. Which means that's a 4, that's a 2. Those are all even. That's a 2 suddenly. That's even. These aren't 8s. These are definitely odd now. That's not a 4. What? How did that happen? All of a sudden. How many 2s do we have? I think I have a lot of 2s. We have a lot of 2s. 2's in one of those 2. And 2 is in one of these 2. Which means it's actually on the thermometer, which is interesting. Can't be there, because then that would have to be a 1, can't be. So that's a 2, that's a 2. Those are both even. These are now, well, not that, but this is now definitely odd. which is huge. Yeah, it's actually huge, because we know Felix is going to end up here. Well, the cell right before it is going to have to be even, and it's not this one, it's not that one. So the path ends like that. That is how Felix's path ends. We know that for sure. That's not, whoops, that's not a 3 or 4. 5, 6, 7, 8, or 9. Not super useful, but we'll take it. It's actually that entire row now. I feel like we're now close somehow. These are 5, 6, 7, 8, 9. Those are 8s. 8 is in there. What other digits do we have a lot of? 1s. We have a few. 3s, not that many. 4s. We have a good amount. 4 is one of these two. 5s, not really. 6s, not really. 7s, not really. 8s. A few more. 8 is one of these two. By Sudoku. 8 is one of these two by Sudoku. Yeah. And 9s, I don't think I have a lot of. No. Okay. Golly gosh. Now what the heck, dude? I was thinking of something and I lost it. What was it? That's bigger than that. It's not super useful. That's bigger than that. It's not super useful. Well, 9, 8, 7, 6 actually take it here. So it's 2. I guess I can draw in this row. This is 1, 3, 4, 5. Which, yeah. There has to be an even digit and non-digit in there, so the even digit is the 4. 4s aren't there. Those are odd. That can't be a 5 because it's on a German Whispers dot. So that's a 1 or a 3, which means this is large. 6, 7, 8, or 9. It's not 7. There's an even digit in there and an odd digit. I don't know, but hold on. 6. 6 could be there, unfortunately. Couldn't, then we could say it's there and that would be useful. But we can't. Wait a minute. Wait a minute. What's going on here? Wait a minute. What's happening here? Look at the green line now. It's in a very weird spot, isn't it? Because now it's in this box. It can't go back to this one without touching itself. So it must go here, but it can't get out through there because this is not going to work. 8 is bigger than 4. That's not going to work by the thermometer. So it must actually get out through here, which means it's going to do that. Which means now this is even, and it's a 4. And that's odd. And that is bigger than a 4. It's not a 5. It's a 6, 7, 8, or 9. It's not a 9, because actually this moves, again, down. So this is a 7, 8, or 9. It's an 8 or 9, actually. And now this definitely doesn't go right, because it's either going to bump into itself or it's going to become too large. 8, 9, nothing. So it goes left into the cupcake. Okay, so we know the ending of the green path as well. Somehow. Still don't fully understand how, but we figured it out. Now what? Now what the heck happens? Great question. Well, now one thing happens for sure. And actually, I think I could have done this before, but I didn't. This is odd, so the digit right before it has to be even. Well, it can't be that one, so it has to be that one. That's even. It's a 6 or an 8. It's not a 2 or a 4. This path can't go down now, or it would bump into the green one, so it must go there, which means that's odd. It's not an 8. It's not a 6. It's a 9, actually. My bad. That's odd, yeah. And now the one before it must be even. Can't be that one. Can't be that one. Can't move that going. It must be that. And then this moves like that. I think that's right. I think so. That's not a 9 anymore. God, that's so weird. That is so strange. It's cool, don't get me wrong, but it's very strange. Okay. So we know the endings of the two paths. I just don't know how they connect, really. I feel like we're somehow close to the end, though. Smaller than that. That's an 8, that's a 9. Okay. One in this box is definitely up there. It's not in those by Sudoku, so that's number one. One is in there by Sudoku. It's not on the start of Felix's path, I just realized, but figure it out in a second. These are 1, 6, 7, 8. Actually, that's not 8. 9. No, not useful deduction. Are we done with 2s? We're done with 2s, yeah. What about 1s? There's a lot of 1s left. Yeah, there's quite a bit of 1s left. Quite a few. Am I missing anything? No, that's smaller than all those. That's smaller than all those. I just have to figure it out, I guess. 1, 6, 7, or 8. Has an equal chance of being odd or even. So I don't really know how that's going to work. The red path. Red path must get to here. It doesn't do that, so it does that. So that is even. It is a 4 or 6. So those aren't 6s. Yeah, that's definitely odd now. That's 5 odds in this column, so those are all even. That is odd. It's a 1, 3, or 5. This must get to there in some way, so it's going to do that. And now these connect like that, and that's good, because it preserves everything we need. Okay, so we connected that part of the path, that's good. Now what? Great question. Great fucking question. That's a 4-6. Because it's even. That's bigger than that. That's a 5, 6, 7, 8, or 9. It's not a 7 or a 9. That's a 6, that's an 8. That's an 8, that's an 8. Okay. Jesus. That's a 4-6 up there. Come on, we gotta be close to done. Can I do this before reaching 2 hours? We have like 15 minutes left. The answer is maybe. Solid maybe. 1. Want me there? Yeah. Good. 1's in one of these two. Do we prove where 9 has to go? No, 9 is in one of these 3. No, it's not. 9 is in one of these two. My bad. Yeah, 9 is in one of those two, so actually that's not 9. It's 5 or 8. Come on, we gotta be close. Gotta be close. We've got to be close. Oh my gosh, I forgot to do a thing. My recording might look weird for a second, but I'll be fine in just a second. So normally when I do this, these videos, I close Discord because Discord has a streamer mode thing, which mutes notifications. I don't want the notifications to be unmuted because I don't want Discord sounds in my video, but I also don't want them to be like fully muted because I still want to know if stuff happens. If there's like an emergency with my girlfriend. So I usually just close Discord and look at my Discord notifications on my phone, but I forgot to do that time. Thankfully, there was nothing. There was no emergencies. But I need to remember to do that. For future recordings. Four is up there by Sudoku. Come on, dude. Come on, dude. Must be close to solving this. Must be. Well, wait, we said these two have to cross now, because this has to get there, and this has to get there. So, mustn't they cross like this? Is that not the only way they can cross? I think it is, yeah. No. Yes. They can't. Oh my god. Yeah, I just got a lot of Discord notifications. Thankfully, they're all from the server, not from my girlfriend. They can't cross like that, because there's no way for this to connect to that. They can't cross like this, because those two are odd. They must. Yeah, they must cross like that. This goes through here, and this goes through there. That's how they must cross, I think. Which is good. Which is really good. I think. Right? Yes. Because now this can't go down. It's not like they're going to cross again. And this can't go through there, so it's going to go up. Which means now this is even, and it is a 6. Haha, there we go. Ooh, we're in it. We're in it now. We're in it now. That's not a 6. That's odd. This goes up. This is odd. 1, 3, or 7. Oh boy. Now what? Come on. So close, man. Just give it to me. Just give it to me, man. All the odds in this column are taken. Those are... Sorry, all the evens are taken. These are odd. Close. Close. I can feel it. Feel that we're close. Just gotta figure out how. I mean, these thermometers work. There's nothing I can really say from those. Alright. Red line is working. Green line, I just need to connect these two pieces, but I don't know how. They might like zigzag a little. I just don't know if that's gonna happen. The only way for this to be a 5 now is if that's a 3, and these connect immediately, which isn't going to work. 3, 5, 1, this is empty. So this can't be a 5. Small deduction, but a win, I guess. Well, that works with 6 as well. Like, for this can't be a 9, by the way. That's pretty obvious why that can't be. If that's a 7, it must connect directly to a 9 right there. And that's not going to work, because that square would be empty. So that's 3, actually. Which means that's 5. That's not 5, that's not 5, that's not 3, that's not 5, that's not 3. That's a 1. 5. Not a 5 there. 3 here. 1, 3. 4 is even. 6. That's odd. 7, 5, 9, 3, 1, 7, 9. 4 goes here. Oh, now we're in the thick of it. Now I think it ends. Now it ends, I think, actually. That's now even, which means that's odd, and it's a 1. And now, finally know how the path starts, because this must move to an even, so it must go there, and then this must move to an odd, so it must go there. 4 goes here. That's not a 5, it's even. That's not a 7, that's not a 7, that's a 9, 5, 7, not a 7, 8, 7, 6, 4, even, odd, 6, 8, even, 5, 9, odd, 8, even, 6, 6, 9, odd, even. This does move directly there. 8, even. That is odd, and that, no. Yeah, these are both odd, which means this must go even, odd. And that is 3, 5. Wow. I actually finished it below 2 hours. I am sort of surprised at myself for that. I'm happy with that result, I'm gonna be honest. That was great. That was really, really good. There were a few parts in which I think I accidentally did bifurcation, where it's just like, oh, let me just follow both of these paths and then see where they fail. But like, I don't know. There's a fine line between logic and bifurcation. It's just sometimes you do need to look a bit in the future and see where something fails. That's just the way these puzzles work. I feel like people are a little too dismissive of bifurcation as a strategy. Obviously, like, it shouldn't be used that often. Simple logic, like logic that doesn't go super, super deep into like 5 steps into the future, is better. But sometimes it's okay, I think. Anyway, after some creative wrangling, we coaxed Felix out of the maze, miraculously leaving both the moose, I thought that was their name. Anyway, Moose and the cupcake unharmed. For his part, Moose focused enough to reach his prize, but showed clear signs of anxiety. Observations suggest this was just as much from the task at hand as it was from the presence of Felix. As this raises ethical questions, future experiments are therefore put on hold. Extremely fair. Extremely fair. Poor Moose. Poor Moose. But, I mean, they did it. Both of them did it. Those were insane paths, by the way. Look at that. Look at all those. Damn. I mean, that was a great puzzle. That was an insanely cool puzzle. That was really, really good. Wow. That was good. That was very, very fun. I actually don't understand the solution code. What is this asking for? Digits on both loops in column 5 and column 8. What do you mean loops? Oh, like lines. They're not loops, but sure. 4, 5, 6, 9, 8. And column 8 has 8, 7, 2, 3, 5, 1. And that should be it. Correct. That was really good. I enjoyed that quite a bit. Definitely 4 stars difficulty. It was hard, but it was fun. It was really, really good. I like these puzzles. I like this puzzle a lot. And that was worked. That was really, really beautiful. Yeah. I mean, if there's more Rat Run coming, obviously I'll do it in the channel. But for now, I guess that's it. I don't really have much else to say. There are a couple Rat Run puzzles that I actually haven't done on the channel yet. Mostly because I just haven't gotten around to them. Actually, I think there's only one. I think it's only the last one, now that I think about it. I hope I'll be able to get to that eventually. We'll see. We'll see. But for now, that's it. Good night.